and served as a member of several international advisory panels and non-profit groups. In appreciation of his outstanding achievements in the field of material science, biology, and engineering education, and for championing the cause of women and minorities, and in recognition of his vision, dedication, devotion, and contribution to the cause of science and society, SRM University considers it an honor to confer on Dr. Subha Suresh the degree of Doctor of Science honoris causa. Your Excellency, the Chancellor of SRM University, it is with immense pleasure that I present to you today Dr. Subha Suresh for the conferment of the degrees of Doctor of Science honoris causa.
I request Professor Subha Suresh to come forward to receive the honorary degree. Also, I request His Excellency, the Governor of Tamil Nadu, to present the degree of Doctorate of Science honoris causa to Professor Subha Suresh. By virtue of the authority vested in me as the Chancellor of SRM University, I admit Professor Subha Suresh to the degree of Doctorate of Science honoris causa in the university. In token thereof, you have been presented with this degree and authorized to wear the robe ordained as the insignia of your degree. I invite Professor Subha Suresh to deliver the acceptance speech.
Much. Your Excellency, the Governor of Tamil Nadu, Mr. Chancellor, Pro-Chancellors, and Vice-Chancellor, distinguished guests, faculty, and students of SRM University. I'm truly honored and delighted to be a part of this convocation. Let me begin with a saying by Dr. Jonas Salk, who's credited with eradicating polio by creating a vaccine for the disease. He said, and I quote, "Our greatest responsibility is to be good ancestors. Whether your studies today are in science, engineering, medicine, management, humanities, or the arts, I hope that your accomplishments as students and as professionals in your career will take you through a lifelong journey that will make you great ancestors. Science and engineering are increasingly seen as the necessary ingredients of innovations by countries large and small. And SRM University has the same vision. Through education, prepare students for innovation. This aspiration by countries large and small, just in the past few decades, have lifted hundreds of millions of people out of poverty. It is the same vision with which my own organization, the National Science Foundation, was created. In the early 1940s, Dr. Vannevar Bush, who was a professor of electrical engineering and the first dean of engineering at MIT, wrote a very influential report called Science, the Endless Frontier. He sent that report to the President of the United States. At that time, it was a revolutionary idea. And Dr. Bush's vision was very simple and straightforward. And he realized, and he articulated in his report, that science and engineering and fundamental discoveries are absolutely essential for innovation, and that innovation best takes place in universities that shape, mold, and nurture young minds, young students, undergraduate students, and postgraduate students. Of course, they work in partnership with industry and national labs. The first time that report was sent, it was rejected. Then in 1950, the President of the United States accepted that report and created the National Science Foundation. I never had the opportunity to meet Dr. Bush, but as Dean of Engineering until last year at MIT, I had the great honor and pleasure of occupying the chair that he once did. And I'm really fortunate to head the agency that was created based on his vision. The National Science Foundation today has a mandate to support all fields of science and engineering, including the social sciences. In its 61-year history, the National Science Foundation has supported the research of 195 Nobel laureates before they received the Nobel Prize, including many of this year's Nobel Prize winners. Just to give you an example, the two colleagues who received the Nobel Prize in Economics just 3 weeks ago both have active NSF-funded research grants. Another example of the impact of science and engineering on humanity and the world. In 1995, the National Science Foundation supported 2 young graduate students at Stanford University to do basic research in mathematics and computer science that at that time did not have major practical applications, known practical applications. The students were Sergey Brin and Larry Page. Their work led to the creation of Google. So did fundamental science and engineering lead to innovation? Did it create jobs? Did it contribute to the economy? Did it change the world? You decide. In the last 61 years, NSF has also supported research, basic research, that led to the discovery or creation of fiber optics, GPS, Doppler radar, magnetic resonance imaging, rapid prototyping, behavioral economics, as well as DNA fingerprinting. Science and education, as well as human capital development, are very much part of NSF's mission. I grew up in Chennai, and as was mentioned earlier, I went to the US in 1977. The students who are graduating here today You are growing up in India at a time that has offered extraordinary opportunity of having a window to the wonderful diversity of ideas and cultures. And India today is a rising star in this very diverse galaxy. So from my vantage point at the National Science Foundation, through various strategic planning exercises, we have the opportunity to ask many questions about the challenges we face in science today, especially in the context of global society. And equally, we ask questions, what is so exciting about science and engineering today compared to, say, 5 years ago or 10 years ago? I can give many answers, but I can give you one very simple answer. There are many, many exciting things about what we do today, but I can very broadly categorize them into two groups. This is what I call the new era of science and engineering in the year 2011. The first exciting part of this is what I call the new era of observation. The research that we support and the tools that we have today enable us, on the one hand, to look at the outer edges of the solar system, discover new planets with a scope, reach, and resolution that is unprecedented. So this is the era of observation in the mega, the giga, and the extraordinarily macro scale. At the same time, we support nano, pico, and femto, really, really small things. We can take a single molecule, a neuron, a cell, a molecule inside the neuron cell in the human brain, and we can study its properties with a resolution that could not have been there 5 years ago or 10 years ago. We not only study the biology at the molecular level of the human brain, we also study with unprecedented resolution the psychology of the human mind, and we combine the two. NSF is the only federal agency that not only supports natural sciences, it also integrates the research of natural sciences into social sciences. And this is a unique and very powerful combination. So the new era of observation is not just from experiments. We have an experimental facility that we just finished at the geometric South Pole in Antarctica, and I'll be visiting that facility 2 weeks from now, right at the South Pole, that does experiments on neutrino physics. And that provides an opportunity not only to do new science on a global scale, but also engage in science diplomacy with 15 countries and use that for education to excite young minds. The new era of observation also comes from computational simulations and modeling, and also from citizen science. You can take a handheld phone, an iPhone or an iPad, point it to the sky, and you can correlate and identify galaxies and stars. So a young child, maybe 5 or 10 years old, in a developing country, can use one of these devices and gather data that can become part and parcel of a real-time data network that is used by an established scientist who may one day receive a Nobel Prize. That's the power of the new era of observation. The new era of observation is also creating a new era of data, information, and communication. So we have unprecedented volumes of data that are created by experiments, computations, and handheld devices and the web that are traveling almost at the speed of light around the world. And we just learned a few weeks ago that maybe the speed of light doesn't have the upper limit that we thought it did. So one of the challenges we have is that the massive amounts of data go unvetted around the world in a nanosecond. So this provides us a challenge in trying to archive, store, retrieve, and also extract meaningful information out of large amounts of data and create useful knowledge out of this and store it for future generations. So we need new science to look into this. So the new era